Today we're going to be talking about relations and functions. And this is a super heavy vocabulary section. So please make sure that you know all of these different terms. And I'm going to be talking about these throughout the video. You don't have to necessarily define them in your notes, but make sure that you understand what each one of these are. And we're going to actually be defining them throughout the actual lesson. So a one-to-one function, each element in the domain, remember domain means the x values, pairs exactly with one unique element in the range. So it pairs with a unique element in the range. Remember the range we often think of as the y's. So each of these elements in the domain is going to pair with an element in the range. Now an onto function, and this is kind of a new term. I hadn't seen this term in any other book but this one, but onto means that elements of the range, so your y's, are pairing with an element in the domain. So when you look at your range, you actually have an output of each one of these. D, C, and B each have its own input, okay? Even though 3 and 4 both get paired with C, each one of the ranges is used up. If you look back at this one-to-one, C isn't used up. So this would be an example of a not onto function, because you have an element in the range that isn't paired with an element in the domain. And then if you're both one-to-one and onto, everything's unique. You have exactly one element of the domain is paired with exactly one element of the range. Every element in the domain is used to every element in the range. Our vertical line test. So the vertical line test tells whether or not a relation is a function. So when you have a vertical line and you drag that vertical line back and forth throughout your function, you're going to be able to tell whether or not the relation is a function. If, as you pull it along, if it only hits one point, that is a function. Your graph is a function. Versus if you pull this along here we hit 2 points. So this would not be a function. Now your horizontal line test. Horizontal line test, so say I have a horizontal line and I promise that's a straight line. If I take this horizontal line, and it's very similar to the vertical line test, as I drag it along, it determines whether or not a function's one-to-one. In this case, I hit at 2 points. So this would not be one-to-one because I hit our horizontal line hits at 2 points. Versus now if I go over here on a horizontal line, I drag it along, up and down, it doesn't hit at 2 points, it only hits at 1 point, anywhere in our graph, so this would be a one-to-one function. Okay, the first example, and we want to state the domain and range of our relation, then we need to determine whether the relation is a function. The function, if it is a function, determine if it is one-to-one, onto, both or neither, and then is our function discrete or continuous? Discrete is a list of points. Versus a continuous function is something like we had in the last example where it's a parabola where I'm tracing along the entire function. Okay, so the domain is all of the x values, and put those in numerical order for me. So -4, -3, 0, 1, and 3. Our range. Okay, let's also put those in numerical order. So -2. Our next one would be 1. Then we have 2, and we have 3. Okay, so just as a reminder, domain is the x's, range is our y's. Okay, So now, okay, so now we need to determine if the relation is a function. Remember how we determine if a relation is a function is we take a vertical line and we drag our vertical line through our graph. Does this vertical line ever hit at 2 points along that same vertical line? I only hit 1 point there. I only hit 1 point there. 1 point, 1 point, 1 point. So this is a function. Okay, now determine if it is 1-to-1, onto, both, or neither. Remember our test for 1-to-1 is if we have a horizontal line. And I was trying to get us a horizontal line so that we could tell the difference. So I have a horizontal line. As I drag that up, look right there. I hit at 2 points. We have this point there and this point there. Or my y's repeat. So it's not 1-to-1. Now, is it onto? Meaning that every range value is paired with a x value. So think about it like this, and I think about the picture that I had on the second slide. So I have -4 is paired with -2. 3 is paired, I'm sorry, -3 is paired with 1. 0 is paired with -2. 1 is paired with 2. And 3 is paired with 3. So each one of these different x values has a y value. I don't have any y values down here that aren't paired with an x. So it is an onto function. Okay, now we need to figure out whether it's discrete or continuous. Since this is a list of points, it's not any lines that go through our function. It is a discrete. It's just a list of points. Okay, our next function, determine the domain or range, determine whether the equation is a function, 1-to-1, all the stuff we just did. Okay, so we don't know. I don't expect you guys right now to remember what that graph looks like. Okay, later on in the year we're going to study what that graph looks like, and I'm going to give you ways to graph it. If you ever don't know how to graph a function, just plug in points. So when I plug in -2, I have an output of an 8. When I plug in -1 for x, I have an output of a -1. When I plug in 0, I have an output of a -4. -1 and 8. So now plot these points. Okay, so this is what that graph should look like. Domain. Were there any restrictions on the x's I can plug in? Could I plug in negatives? Yes. Could I plug in 0? Yes. Could I plug in positive numbers? So that's all real numbers. And that's where we're going to be using those sets that we talked about in chapter 1. The range. Okay, so when I was graphing this, what's my lowest y value? My lowest y value is down here at -4. So y has to be greater than or equal to -4. And in interval notation, a lot of teachers use interval notation for this. That's -4 to positive infinity. Is it a function? Okay, when we have our vertical line. When I drag that vertical line across, We only touch at one point. So, yes, this is a function. Is it 1 to 1? So when I have my horizontal line, for most all of the points, we hit it 2 points, except for the vertex down there. So we hit it 2 points. So this is not 1 to 1. Is it on 2? Every y is paired with an x, so yes. Is it discrete or continuous? Is it a list of points? Yes, I used a list of points to get what my graph looks like, but I have points that are in between here. I have points in between -1 and 2. It's a function that I just trace through. So it's not discrete, but it is continuous. Okay, this is function notation. Okay, given the function, find each of the following. This is function notation. In function notation, instead of having a y on this side, it tells me g is a function of x, and that's my equation. So what changed in these two notations from g of x to g of -2? The x became a 2. So all that means is we have 2x cubed minus 5. But what was my x? My x was a -2. So now simplifying that all out, we get the answer of -21. Now in this case, we have, that's my new x. So I plug that in wherever I see an x. So I have 2 of something squared minus 5. I have 2 of 3t squared. Simplifying that out. Make sure the 2 goes to both. So I have 2 times by 9t squared. The exponent gets distributed to both. Minus 5. Really, this is like saying 2 times 9 times t squared minus 5. And I just realized I made a mistake. What was my mistake? That should have been a 3. So let me fix that for you guys. That's going to change what's in there. So I should have here third power. Okay, that's a little bit better. So now what's inside my parentheses? 3 to the third, which is 27 times t cubed. So I have 2 times by 27 times by t cubed minus 5. 2 times 27 is 54. T cubed minus 5. Okay, linear relations and functions. Again, this is a little bit of a review from Algebra 1. Anything that has a linear function, okay, all you really have to write down is linear versus nonlinear for me, okay? You just have to write down every variable has an exponent of 1. Here, that has an exponent of 2. That can't happen. No variables can be multiplied together. Okay, I have a number times a variable. Here, I have 2 variables being multiplied together. No variables in the denominator. There, I have a variable in the denominator. And then no exponents greater than 1. Exponent greater than 1. Technically, that's a square root. It's a fractional exponent, so that would not get me a linear. Notice how all of these are linear. Okay, standard form. It's a form that we're going to be seeing a lot when we get into some word problems in Chapter 3. So that's our standard form. So all you can write down is write down standard form ABC, AX plus BY equals C. Okay? So what we need to get is the X and Y's on one side, where A, B, and C are integers. Okay? so they need to be positive or negative whole numbers. So I need to get rid of these fractions. Think about how we cleared fractions in the last chapter. I need to multiply by the common denominator, which is 6. Multiply each one of those terms by 6. When I go through and I multiply each one of those terms by 6, we get 4x plus 5 equals 3y. Basically, subtract the 3y over, subtract the 5 over, a is equal to 4, b is equal to negative 3, and c is equal to a negative 5. Now, why is this form so important? This form is so important, and we can get a quick graph when we use the intercepts. So x-intercept, point where the graph crosses the x-axis. So if a point crosses the x-axis, which is this one, think about what variable is going to be 0. The y's are going to be 0, so we make y equal to 0. The y-intercept, where it hits the y-axis. All of those are y values, which means x equals 0. Okay, so I like to make what I call an intercept chart. I do a 0 for the x, 0 for the y. Okay, so if I make x 0, so if I plug in 0 there, 3/4 times 0 minus 1/2 y equals 3. Anything times 0, 0. So what I often do is with my finger, I cover that one up. When I'm finding the y-intercept, I cover up the x term, and I solve this equation. Solving that equation, I get negative 6. Now to find the y-intercept, to find the x-intercept, I make y equal to 0, so I cover that up with my finger, and I solve that equation. So I multiply both sides by 4/3, the reciprocal. Those cancel, and I get my intercept of 4. So now it's a matter of graphing. So I have negative 6 to and 4, and then using your ruler, connect your 2 points. Okay, there are your 4 lesson questions for the day. Please make sure those are submitted on time for me.